Okay, we're moving on to the next concept in the theory of interest. So first we will touch on the other form of interest rates. First is on the fractional effective interest rate and fractional effective rate of discount. And then we will go through the nominal rate of interest and nominal rate of discount. Okay, first, fractional or mthly effective rate of interest and mthly or fractional effective rate of discount. Okay, let's say P is a fraction of the year. For example, semi-annual. And M is the number of sub-period that we are splitting our year. So if our sub-period M is 2, then our P is going to be half or semi-annual period. Okay, so to get the non-annual rate of interest, let's say we call it J, the following relationship will hold. 1 plus the annual I is equals to 1 plus the fractional I, which is J, to the power of M. Let's see an example if we are doing it for the semi-annual period. So 1 plus the annual I is equals to 1 plus semi-annual interest, which is J, to the power of 2. Okay, let me illustrate what's going on. This is our period, between 0 and 1. And this is half of the year. Okay, so our accumulated value factor A1 is equals to 1 plus I between 0 and 1. And it is also equals to 1 plus J times 1 plus J. So it is equals to 1 plus J to the power of 2. Okay. This relationship is only true if the interest rate within the period is constant. If not, then this relationship doesn't hold. Okay. So once we already know this relationship, then we can derive the formula that we need to find J. So you just adjust this relationship to get the formula for J. So J is equals to 1 plus I to the power of 1 over M minus 1. Okay. So you don't need to remember this formula. You just need to understand this relationship and you can easily derive this formula. Okay. So same goes to the discount rate. Same concept goes to the discount rate. So 1 minus the annual D. If you remember, 1 minus D is the present value factor, right? V. Okay. So 1 minus the annual D is equals to 1 minus the fractional D, or I use the notation K, to the power of M. So yeah, if you want to illustrate, it's the same. So the present value factor between 0 and 1 is 1 minus D. So present value factor it's also equivalent to 1 minus K times 1 minus K. Okay. Alright. So moving on to the next section. Oh, this is an exercise. Okay, let's say we are given I. If we are given I, let's say we are given I. So how can we find the equivalent semi-annual effective interest rate, which is J that is semi-annual? How do you find it? So like what we know just now, it's 1 plus I to the power of 1 over M plus I is 1 plus I to the power of 1 over m minus 1. So it's 1.09 to the power of, for this case, to the power of half minus 1. So you will get J is equals to 4.403. For the quarterly effective rate, you just change this part. So you get 2.178. And for the monthly effective rate, you just change this part, you'll get 0.72%. Okay, so how about the, if you know I, you want to find annual effective discount rate. Okay, this one I really hope you remember this relationship. D is equals to the discounted version of I, correct? So you can write it as D is equals to I times 1 over 1 plus I. V is 1 over 1 plus I. Okay, remember? Or we can also write it as I over 1 plus I. So sometimes we write D is equals to I over 1 plus I. Sometimes we write it as D equals to IV. Okay. So in this case, we will do I divided by 1 plus I equals to 8.257. How do you get the semi-annual effective discount rate? So if you remember the relationship just now, 1 minus D equals to 1 minus K to the power of 2. So from this, you find K. So K is going to be 1 minus D to the power of half. Oh, 1 minus D to the power of half. 1 minus D to the power of half. So that is K. So when you do this, you'll get semi-annual discount rate is 4.217. And then you do the same, but you change this. So instead of 0.25, it will be 1 over 4. And then for this one, it will be 1 over 12. Okay, once you do all of this, you will get the following answer. Okay, please try to pause this video and try it yourself. Okay, so I just want to highlight this one thing. If you see, between the semi-annual I and the semi-annual D, it is the semi-annual D is a smaller number compared to the semi-annual I. Same with the quarterly. Quarterly D is smaller than the quarterly I. Same goes to the monthly. So again, the same relationship hold. D is basically the discounted version of I. So in the fractional case, K is the discounted version of J. Right, but you have to be careful with the discounting factor. V is the discounting factor, right? Present value factor. So the V have to be suitable with the period that we are dealing with. So for the semi-annual K, your present value factor have to be the semi-annual present value factor. So for the semi-annual case, K is going to be J. The J for the semi-annual is 4.403, right? So 4.403% times the V. So the V is going to be 1 over 1 plus J. 1 over 1 plus J, which is 4.403%. Or the semi-annual present value factor, you can also write it as V to the power of 0.5. Okay. So, yeah, I just want to highlight that part. If you want to find the fractional discount rate based on the fractional interest rate, when you are choosing the discounting factor, make sure you are using the right discounting factor that is suitable for the period that you are dealing with. If not, you can just find the annual discount factor, you find the annual discount rate and then derive the fractional discount rate accordingly. Okay.